Assalamu alaikum and good morning everyone. My name is Mahmoud Rafi. I will be presenting module 3 assignment. The topic is ROV, spread inventory and terminology. The ROV, spread inventory and terminology is explained in 3 sections. They are structure system, electrical system and hydraulic system. Firstly, for the ROV system, as we can see, the structure system of ROV, it covers with the crash bar to protect the ROV if it collides with any object in front or side. The first part of the structure is junction box, where it contains wiring and supplies power to the motor, and the motor will convert electricity to mechanical into pump, where the pump will pump in hydraulic, and some of the hydraulic part contains bleed port, which is to release the air in the hydraulic oil, and mostly bleed part is located on the top of the part, and the bottom one is the drain port. It is to drain the hydraulic oil in the ROV, the bottom part. Then it follows through the high pressure filter. It is to filter the hydraulic oil. Then it follows through the main compensator, and in the body of ROV contains 5 thrusters. As you can see in the diagram, 2 thrusters are located at the back of ROV, here and here, to maneuver the ROV itself, follows with the port of ROV. Then another thruster on the right side and another thruster at the middle of the ROV. Then there is a transmission control unit or TCU at back to control thruster compensator, and follows with transformer, motor and manifold pad to control the hydraulic oil in the system, and it follows with the depth transducer, and lastly it will go to the light, camera and manipulator. As you can see, the first picture is MCP, which stands for main control port, follows with HCU, which stands for hydraulic control unit, which acts as a reservoir for hydraulic oil in the system. The next is high pressure filter, then the main compensator, pump, and then TCU or transmission control unit, and then junction box, depth transducer, and then crash bar and the frame. First is umbilical cable that goes through the block, and then followed by a bullet. Then it goes into the lifting column, and in this picture we can see in front of the ROV there is a crash bar, and following that umbilical cable will go inside the oily junction box. For the top view of ROV, as you can see, we have buoyancy on both sides of the ROV, and then in front we have the crash bar. Now I would like to talk about the electrical system. So in the ROV, first the power will come through the umbilical winch to the junction box. Then the power will divide into motor, transformer and main control port, MCP. And from motor it will power up pump to pump the hydraulic oil, and from transformer it will step down to 24 volt to power up the light, and transformer will also power the MCP, and MCP will power up sensor, for example gyro, transducer, and the MCP will also power the camera, hydraulic control unit HCU, and thruster control unit TCU. Now I would like to talk about hydraulic system in ROV. As you can see, the power usually starts from the motor to turn on the pump, where the pump will pump in hydraulic oil in the system. Then it follows to high pressure filter to filter contaminants in hydraulic oil, and also to protect the system from damage. Next, it follows to the TCU, also known as servo valve pack, and it also controls the thruster in the ROV. Then it goes to two parts of the ROV. First one is HCU, hydraulic control unit, also known as solenoid valve pack, where it functions as reservoir for hydraulic oil in ROV. Second one is also goes to the water filter. It is to filter the water in the oil. Then it follows to the main compensator, where it regulates the system by distributing the hydraulic oil in the system, and it will follow back to the pump and follow another cycle. Now I would like to talk about control van electrical flow. Control van will get power from genset, which is 480 volt. It will send to power cable, and power cable will send it to changeover switch. This is a picture of changeover switch. It will be divided into two. First is the domestic transformer and the second one is PDU. For PDU, they have two connections here, which is MCBV and the contractor. The current will flow from PDU to transformer here. At transformer, they have two three-phase and one single-phase connection, and this transformer will go to the junction box. And here, for the domestic single-phase transformer, that will supply the current to the PDU control rack screen, which consists of overlay PC, reporting PC, sonar PC, and pilot PC. And domestic transformer also will power up the control van. PDU control rack screen will also give signal to the contractor, which means contractor will get signal to open up the system and to give the signal to the transformer. Now I would like to explain about the electrical diagram of launch and recovery system. We will start from the deck cable. Deck cable will go through the umbilical winch, which is static junction box. Then it will go to the slip ring drum. From drum it will go to the rotary junction box inside the drum, followed by umbilical winch. Then it will follow to the level winder. Level winder's function is to align the umbilical cable. Next it will go to the ROV. Is the hydraulic diagram for the launch and recovery system. The function of hydraulic van is to pay in and pay out the airframe from onboard and inboard. The line 100 line is from the HQ hydraulic power unit, then directly to the valve pack control. And they have two line of hydraulic winch. The first one the first one goes to the front of the hydraulic piston, and the second one goes to the next to the hydraulic piston on both sides. If we want to pay in, then we will have to pull the joystick on the valve pack control. If you want to go on board and launch the ROV, we need to pull out the joystick on the above valve pack control. Then the function of toggle is to decode the ROV, also to recover the ROV. I would like to finish my presentation. Thank you for your kind attention.